Hello all, welcome to the presentation on T-flipflop. So this is the last flip-flop which we'll be discussing on, as in the first we have discussed about SR flip-flop, where we have seen the input S and R were 1 and 1, the case was not used case. In order to eliminate SR, we have come up with data flip-flop. In the data flip-flop, as you can see, whatever the input you were providing, the same output you were getting. So that was the concept for data flip-flop. Then moving on further, in order to make this 1 and 1 a valid case, we have evolved out with JK flip-flop. But the JK flip-flop, which we found the drawback was a race around condition. In order to eliminate this race around condition, we can have the clock to be negative triggered. Now, what if J and K are sorted out together? That means what if J and K has a common input? That means I will be having either the case j equals to k equals to 0 or j equals to k equals to 1. That means I'll be left with two cases. So you can see if t, that is j is equals to k equals to 0, it will hold the value for memory, and j equals to k equals to 1, just toggle the case. That means j equals to k equals to 1 implies it will be the case of toggle. So what I can do is I will be having the cases as, so as you know already, when clock is 0, irrespective of whatever j and k, in this case t, my output will follow memory. If clock is high, in the case what we'll be doing, we will be having cases t 0 and 1. If both are 0, it will hold memory. If it is 1, it will toggle the previous state. So output will be q of t bar. So this will be the truth table for to the state table. So what would be the state table? State table would be nothing but you will be having inputs as, say, this is my q of t, this is my t, and this is my q of t plus 1. So if the inputs 0 0 0 1 1 0 and 1 1, so as t is 0, it will hold the value. When 1, it will toggle, 0 becomes 1. If 0, it will hold the value, and if it is 1, it will toggle the value. So as you can see, 0 0, the output is 0, for 0 1 output is 1, for 1 0 output is 1, and for 1 1 is 0. That means q of t plus 1 is nothing but q of t XOR with t. Let us move to the third case, that is, let us draw the excitation table for it. So for excitation table, I will be having q of t and q of t plus 1 as my input, and t will be my output. So let us me have the case, I will be having 4 cases as it is 2 input. So the cases should be something like this. As you can see, if the present input is 0 and the output is 0, that means t will be 0. For 0 and 1, as it is toggling, so t means 1, 1 0, as it is toggling the case, so it will be 1, and for 1 and 1, same, that means t is 0. So you can even say t is nothing but qt XOR with q of t plus 1. So this is the way how we design the excitation table, state table. Let us talk about the timing diagram. Say this is my input clock, this is my t, and this is my output q of t. As it is negative age triggered, that means for the falling age, the output will be triggering, and for the positive age, it will hold the value. So what will happen for clock? Imagine q of t to be 0. So for till here, it will be following the previous state, that will be 0. When t is 1, it will toggle the case. That means 1 becomes q of t. If it is 0, that means the next output will be 1. Till where? Till it will be here. Now as you can see, t is still 1. 1 means it will toggle the case. So my previous output was 1, so now it will be 0 till here, as it will hold the memory. Now if you see over here, the t is considered to be what? 0. T 0 means it will hold the previous value, so it will hold 0 till the next upcoming cycle. And as in this cycle, if you see t is 1, so it will toggle the case, that means it will follow like this. So this is the way how we design q of t. I will explain you again. For clock, for as this is negative age triggered, as we have seen, we have, in order to avoid the race around condition, what we have done is we have inserted a NOT gate before applying the clock. So it is negative age triggered. So what I will be doing is I have just given an input t. Initially, I have assumed q of t to be 0. For till here, the output will be following the previous output. When t is 1, as you can see over here, if t is 1, it toggles the case. That means 0 becomes 1. So the 0 becomes 1. In the next case, again, it is high. T is made as 1 for the next clock. 1 means it will toggle the case. So our previous output was 1, now it will be 0. Till here. Now as in this case the t is made as what, 0. 0 means it will hold the value, so till here it will be holding the value. Now as you can see t is 1, so it will again toggle the case. As the previous state was 0, now it will be 1. So this is the way how we design the timing diagram for t flip-flop. So I hope truth table, state table, excitation table, timing diagram and the basic concept of the toggle flip-flop is clear to you all. Thank you.